Section 1.2, the slope of a curve at a point. So the idea here is that let's say we have some function. Okay, so I'm going to say that this is just some arbitrary function, f of x. And then what's going to happen is we're going to take this thing called a tangent line. And what we're going to do is we're going to take a point on the function and mark it as the point P. And so this is the point P. And so what's going to happen is we're going to say that the slope of a curve at a point P is defined to be the slope of the tangent line. And we'll talk about a tangent line in just one moment. But the idea here is that if you have this function f of x and then you pick a point on the curve, then you can find this thing called the tangent line. Well, the tangent line is going to touch the line just at the point P, but it's going to be a straight line. And so this is what I mean by tangent line. It touches at a point, but it's a straight line that's close to that function. Now specifically what becomes interesting here is that if you were to zoom in to this point P, what actually happens is the closer that you zoom in, the tangent line should almost be indistinguishable from the curve itself. Okay, and so this is a bad picture, but this is the idea, is that as you keep zooming in, sooner or later, this is going to be a good representation of what the rate of change is of a function. And so once again, here's that point P, and so the tangent line is almost indistinguishable from the function as we zoom in. Since this tangent line is a line, then it's going to have a form y equals mx plus b. It's just a line. It works really well. And of course, because we have a line, we can find the slope. Now in general, you can estimate the slope of a graph at a point by drawing a tangent line to the curve at that point P. So you've got to pick a point P and then draw a line tangent to the curve at that point P. Then at that point, if you're just trying to find or calculate the slope, then you can move one unit in the x direction, and then the change in y will literally be your slope. Now this is just true because that's what slope is. And of course recall that when we're talking about slope, up is positive and down is negative. Now at this point, we're going to find the slope of the tangent lines specifically to the function f of x is equal to x squared for three separate points. So these are our points P. Okay? X is equal to 1, x is equal to 0, and x is equal to negative 2. Now specifically that's not the entire point, that's just the x coordinate of the point on the graph f of x. And so if we were to let x equal 1, then we can calculate what is f of 1. Well, because this function is x squared, that's going to be 1 squared, and so we now know that the y point is 1. And so this point P is equal to the ordered pair 1, 1. And in general, you can always find that point P because of the properties of functions given some x. Well then, notice that the tangent line is already drawn for us. And so this tangent line, we just now have to find that slope m. What is the slope? Well, let's find it. We're going to go to the right 1, and then let's count how much up we go. 1, 2. So 2 over 1 is our slope, or just 2. And so specifically the slope of the tangent line to the function f of x is equal to x squared at the point 1, 1 is 2. So that's the slope of the tangent line at that point. Then the next point we're going to use is 0. Once again, you can plug in and calculate what is f of 0. F of 0 is just going to be 0 squared, which is of course 0, which means that this point for 0 is the point 0, 0. So there it is. Then we draw the tangent line to that. Now we want to calculate what is the slope of this tangent line. Move right 1. We go up none, down none, so that's 0 over 1. Our slope is 0. So that's the slope of the tangent line at the point 0 for this exact same function. Then for negative 2, where is that point? So f of negative 2 is negative 2 quantity squared, which is 4, which means that the point P that we're working with is the point negative 2, positive 4. Notice there's our point P, negative 2, positive 4. Then the tangent line is currently drawn for us. And so now what happens? Let's go to the right one. Let's find that slope. We're going to go to the right one, and then let's see how far down we go. 1, 2, 3, 4. So that's going to be negative 4 over 1, or the slope of the tangent line here is negative 4. Once we know how to find the slope of the tangent line, then we can extend that concept and we can actually find the equation of the tangent line given the information we already know, which is point slope form, y minus y1 is equal to m times x minus x1. And so if we have a point and we have the slope, then we can get the equation of this tangent line. So step 1, we're given the x value, so we need to actually find our point. Alright, so let's find this point P. This point P is going to be what? Well, I know it's labeled here, but let's say you didn't have the picture. How would you find it? You would take the x-coordinate of the point P and plug it into the function. That's f of 1 is then going to equal negative 1 cubed. Well, notice that it's really positive 1 cubed, which is 1, made negative, so that's negative 1. And so that point P is 1, negative 1. Now, of course, it was already labeled for us, but you won't always get the picture. And so we can now have this point. Now, in terms of our equation, this is going to be our x1, y1, because we know that that has to be a point on the tangent line. That's how tangent lines are defined. It's just where it touches that point on the line. The next thing we need to do is find the slope. Well, since we have the image, we can calculate the slope. Now notice we're kind of stuck here because I can anticipate where this goes towards the bottom, but it's not on the graph, so I'm going to avoid that one, and I'm going to change it up a little bit. To find the slope, I'm actually going to go left 1 and then count up because I see it's on my graph. And so since I'm going left 1, that's negative 1 on the denominator, and then up 1, 2, 3. So that's positive 3 over negative 1. Our slope is negative 3. Then to find the equation, we just plug it all in. Y minus 1 is equal to negative 3 times x minus 1. That's going to be y plus 1 is equal to negative 3x plus 3. Then solve for y. Minus 1 minus 1. Y is equal to negative 3x plus 2. I'm just used to putting in function notation or y equals notation, and so that's how I'm going to present the answer. So now for this example, we're going to do two things. First, for each labeled point, we're going to indicate whether the function value is positive, negative, or 0. Function value means a y value. And so we're looking, what is the output? What is the y value? Is it positive, negative, or 0? The next thing we're going to do is we're going to sketch a tangent line, just to keep us on track, and then we're going to say whether the slope of that tangent line is positive, negative, or 0. And as a refresher, if you're thinking about slopes, then they're going to look like this. Well, there's the positive case, the 0 case, and the negative case. For positive slopes are going to be if you look at a graph from left to right and that line increases, that's going to be positive. If you're looking at a graph and it's horizontal or flat from left to right, then the slope will be 0. And if you look at a line from left to right and it decreases from left to right, that's going to be a negative slope. So we're really just thinking about these generals. Does it increase from left to right, flat from left to right, decrease from left to right? That's how we're going to get the slope being positive, negative, or 0. Well, then let's look at A, and let's do a 1, which is the labeled point A positive, negative, or 0? Well, notice that that point falls on the x-axis. Now, I'm noticing that this is the origin 0, and so that's how I know that this is a 0 point. Specifically, I'm going to use the function notation since that's the x value negative 1. That is, f of negative 1 is equal to 0. Then, we need to consider what is happening with the tangent line. Well, you need to sketch the tangent line. Or, if you're looking at it and you recognize that the tangent line looks something like this, well, that's actually decreasing from left to right, and so the slope is going to be negative. Then, moving on to point B, Well, point B, that's actually the exact same situation we just talked about with A. B falls on the x-axis, so that is f of 0 is equal to 0. Then we're going to consider the slope of the tangent line. So sketch that tangent line in. Looks about like that, but when I see that, I see that the slope, and I'm going to change my notation a little bit, my slope here is actually going to be positive, right? It's going to be bigger than 0 or positive because as we look at that tangent line from left to right, it increases. So the slope is positive. Well then, how about C? Well, C1. What is the output? Well, specifically, that looks to be about a half. If I wanted to use the function notation, I could, but I'm also just going to say the point C is positive. Because we can see that that C value is above 0, so must be positive. Then to find out about the tangent line, but this one, it kind of looks like if I made the tangent line, it would look like that. It would be flat. And so I'm going to say that the slope here is 0. The point D is 0. And then if we consider the slope of the tangent line would look something like this. And as I read left to right, that's decreasing, so I'm going to say that the slope is negative. Okay, slope is less than 0, therefore negative. Then for point E, well, is the point positive or negative? Well, the point is below the x-axis, so that E1 point E is negative. And then considering the slope of the tangent line for E, well, the tangent line should look about like this, which still decreases as we move left to right, so that is the slope is less than 0 or negative.